Hey guys, welcome to part 1 for the 2018 level 2 waves, okay? It's getting quite late, so I'm just going to get straight into it. Question 1, the enlarged eye. Sophie and her friend John were investigating magnifying glasses, convex lenses. Sophie laughed as the size of John's eye appeared when he placed the lens over his eye. Complete the following ray diagram to show how John's eye, the object, appears enlarged as in the photo. Clearly indicate its size and position. Okay, so once again, we're going to draw the ray diagram here, okay? So we're going to be drawing the ray that is perpendicular to the lens, okay? So the one's going from the top of the image and it's perpendicular. Okay, so it's going to be traveling straight perpendicular to the convex lens, and then we're going to draw. We're going to finish this ray first, okay? So when the ray hits the convex lens, it's going to refract, and it's going to bend, and it's going to bend, and it's going to bend and hit the focal point, okay? So it's going to bend, and it's going to, when it comes out of the convex lens, okay, it's going to bend and pass through the focal point, okay? So that's our first wave. Our second wave, okay, is going to go exactly directly towards the convex lens, okay, and it's just gonna pass sorry, and it's going to pass directly through our convex lens. Okay, so here we have our two rays. Okay, so these rays they do not meet. Okay, they do not meet. Okay, so hence this is a virtual image once again. Okay, so this will be a virtual image, and therefore we're going to be dotting back our rays. Okay, so our rays we're going to dot it back. Okay, so we're just going to put this back, and we're going to also put ray number 2 back. Okay, so at the point they meet, which is here, that's where our object will be created. Okay, not object, where our image will be created. Our object will be created. It's funny. So our object will be created here. Okay, so as you can see, this is a virtual image. It's enlarged and it's upright. Okay, so that's our image drawn, and this will get you an achieved grade here. Okay. The lens has a focal length of 12 centimeters. John holds the lens 5 centimeters from his eye. Calculate the distance the image is from the lens and state the nature of the image produced. So we have our focal length equals to 12 centimeters. In a convex lens, okay, the focal length is positive, okay? So John holds the lens 5 centimeters from his eye. So his eye is 5 centimeters away from the lens, and the eye is the object, okay? So our distance of object is 5 centimeters. And the distance of image we must find. So distance of image we don't know. We're going to use the equation 1 over f equals to 1 over do plus 1 over di. Not do, plus 1 over di. 1 over 12 equals to 1 over 5 plus 1 over di. Okay, so so therefore 1 over 12 minus 1 over 5 equals to 1 over di. Di equals to 1 divided by 1 over 12 minus 1 over 5. Okay, and that should give you your di to come out as negative 8.6 centimeters. Okay, so therefore our distance of image is negative 8.6 centimeters. Okay, and to get that we have our properties. Okay, so it is upright, enlarged, and virtual. Okay, and getting the correct distance of image, okay, that'll get you the what am I doing? That will give you a merit grade here. Okay. Okay, so basically what am I saying? Distance of image, yeah. So therefore we're going to have our if the eye of object, okay, has a height of 2 centimeters, calculate the magnification and the height of the image of the eye, okay? So we need our magnification and we need the HI, okay? So what is magnification and what is HI? Okay, we have our DI equals to negative 8.6 centimeters, okay? We have our, okay, so basically magnification magnification equals to we have our di equals to negative 8.6. Our do equals to our do equals to 5 centimeters. Okay, so do equals to 5 centimeters. Focal length equals to 12 centimeters. Okay, so we're gonna say our magnification equals to di over do. Magnification therefore will equal to magnification equals to negative of 8.6 divided by 5. Okay, so therefore our magnification comes out to be negative 1.71. That's our magnification. And we're going to calculate our height of the image. Okay, our height of the image, so that's di over do. Di over do equals to hi over ho. Our di works out to be negative 8.6 divided by do, which is 5. That equals to hi, we don't know, divided by ho. Okay, ho, we height of the object, height of the object we do not know. Yeah, height of the object we do not know, sorry. Okay, so basically we know that hi over ho is also equal to magnification. So hi over ho equals to negative 1.71. Okay, so basically we're going to say that basically we're going to say so how we're going to work this, we're going to work oh, sorry, if the eye object has a height of 2 centimeters, okay, we do have the hi. Okay, we do have the we have a hi, okay? So we know our hi, we're trying to find out our ho, okay? So, so what is the height of the object, okay? So therefore we have our hi is 2 divided by ho equals to negative 1.71. Wait, no. Doesn't sound right. Wait, sorry guys. So if the eye object has a fine. Sorry. So no, height of object is 2 centimeters. Sorry. So height of the object is 2 centimeters. Sorry. So hi divided by 2 equals to negative 1.71. So therefore hi equals to negative 3.43 centimeters. Okay. And getting the correct answer for both the hi and the magnification gets you a merit grade. To get an achieved is any one of them. So either the magnification or the hi will get you an achieved. Alright, moving on. John cannot see the image of his own eye by looking through the lens. He decides to put the lens down and select one of the 3 types of mirror: plane, convex, or concave. Which type of mirror will give the best upright and magnified image of the eye? So for the concave mirror, we know for the concave mirror it will produce the magnified image. Okay, so our concave mirror, we have our object here. So it's gonna look something like this. So our object's gonna hit the concave mirror. Okay, it's going to go back down towards the focal point. And our second ray, okay, is going to fract, and it's going to bend at the same angle theta. And if we drop this, so theoretically, if we drop this back, we'll get the enlarged image here. Okay, so this is enlarged. Okay, so basically we'll say that which type of mirror? So say that the concave mirror is the best choice. Okay, a concave mirror is needed. It's needed. It produces the magnified virtual and upright image of the eye. The convex mirror produces the diminished image. And our plane mirror, okay, so if we have our plane mirror here and we have our object, the size of the object doesn't change, okay? So whatever the size of the object was, it's going to be the size of the object after, okay? So therefore our height of the image equals to height of the object, so therefore our magnification equals to 1. So therefore there is no m equals to 1 for plane mirror. Okay, and where would John's eye need to be positioned to get an enlarged upright image for your choice of mirror? Okay, so for the concave mirror, okay, we need to have our eye inside the focal point, okay? So if you have our axis here, if we have our focal point here, our object needs to be inside the focal point. Let me do a demonstration, okay? So if we have our object inside the focal point, okay, so it's going to travel towards the axis. It's going to oh, what am I doing? That's not right. Sorry. It's going to bend back towards the focal point like this, and the second ray is going to travel down and then reflect at the same angle theta. And if we drop these images back, these rays back, okay, that only then we'll get the enlarged image, okay? So the image is larger than the object. But if our image is outside the focal point, there's a problem, okay? That becomes a big problem. So if our image is here, so the first ray will travel to the concave mirror. It's going to bounce back towards the focal point. The second ray is going to go towards the horizontal axis. It's going to reflect at the same angle theta. So now if we draw it back, okay, sorry, it's not really, so it should be more like, okay, so now if we draw it back, okay, so okay, I think this isn't really working out. Okay, so it doesn't work with the, if I just use arrows, you'll understand better. Actually, it's not very good to use inaccurate drawings. Okay, so basically, okay, we have our we're gonna have our image. Okay, I have our image here, and if we have our focal point here, okay. So basically, we're gonna draw our first ray. Okay, it's gonna hit the concave mirror, and it's going to bend back towards the focal point. It's gonna look something like this. Okay, our second ray. Okay, is gonna travel directly downwards towards the horizontal axis. It's gonna bend back at angle theta. Okay, so as you can see, okay, so as you can see, if it's outside the focal point, okay, our point of intersection, okay, between the two rays, will be this point here, okay, and our image will be produced. It will be produced as a real image. The rays actually touch. It will produce a real image. Okay. Oh, dang it. Good job. Just get out of here. Okay, so it'll produce the real image. Okay, but it will be diminished. So it's gonna be smaller, and it's going to be the opposite way around. So we're gonna say that it's inverted. Okay, so we have an inverted image. Okay. So therefore, our where just shown I need to be positioned inside the focal point. So distance of object is less than focal point. Okay. Clearly explain where John's eye would need to be positioned to obtain the largest upright possible choice for your mirror. Okay, so therefore, okay, so because that 1 of f equals to 1 over do plus 1 over di. Okay, so as do gets closer to a focal point, so as the distance of object gets closer and closer to a focal point, okay, so therefore 1 over f minus 1 over do gets closer and closer to 0, okay, and 1 divided by a very small number, so 1 divided by a very, very low number, that will give us a very high output, okay? So therefore, our DI will be very, very high. So if our DI is very, very high, okay, and we have our DI over DO equals to HI over HO, our DO is very close to a focal point, and we have our very high DI. So I have our extra large DI, okay? So therefore our HI will also increase, okay? So therefore DI HO equals to DO HI. Okay, so therefore if our DI increases, if our DI is up, then our HI will also go up, okay? Okay? That's basically the explanation behind it, okay? So therefore we can say that our so to put this in words, okay, we're going to put this explanation in words. We're going to say as the eye gets closer to the focal point, DO gets similar to F. 1 over F equals to 1 over DO plus 1 over DI, and 1 over F minus 1 over DO equals to 1 over DI. Because 1 over F is similar to 1 over DO, then 1 over F minus 1 over DO will be very close to 0, okay? 1 divided by I, okay, so therefore 1 divided by a small number gives high result for DI. Okay, because DI divided by DO equals to HI over HO, so because DI over DO equals to HI over HO, therefore high DI will give a very high HI. Okay. Okay. So, however, okay, we're gonna say that however, John's eye cannot be at the focal point. Because then 1 over F equals to 1 over DO, okay? And therefore 1 over F minus 1 over DO equals to 0. 1 divided by 0 is impossible, so therefore this is an impossible scenario, okay? So it's important to keep that in mind, okay? So for this question, you can get an overall question, you can get an excellence grade. Okay, so getting excellence grade, that means you're justifying your choice correctly. So justifying concave mirror over so you're justifying your concave mirror over your convex mirror over your plane mirror. You're saying that the eye must be inside the focal point. That's question II. And you're saying the physics theory behind it with the equations. Okay, so all 3 of these points will get you an excellence grade overall. Okay, so basically to get a merit grade, okay, so you're saying that the concave mirror stated correctly, so you're just stating the concave mirror, you're stating why the concave mirror is better, or you can say that DO is greater than DF, DO is greater than the focal point, not greater than, so you can also say that DO is less than the focal point, or you can draw the, you can say that the largest image is formed when the eye is very close to a focal point but not at it. Okay, that'll get you a merit grade. To get an achieved grade, you're simply stating that the concave mirror is the best mirror for the situation. Okay? Alright, thank you for watching this video, okay? I'll see you tomorrow for the question 2 and question 3 walkthrough, okay? But for now, it's getting really late and I'm getting pretty tired. As you can see by a lot of stuttering in the video, I apologize for that, okay? But I hope to see you in the next video. Thank you for watching. Bye.